Associate Professor in the Department of Computer Science and Engineering, Rohini College of Technology. I am going to take the topic processes and process concept in the subject operating system. The subject code is CS893. The objective of this topic is to understand the concept of processes in operating system and process management. Processes. So the outline of my presentation is process concept, process scheduling, operation on processes. Subjective to introduce the notion of a process. A process is nothing but a program in execution which forms the basis of all computation. That to describe the various features of processes including scheduling, creation and termination. To describe communication and service systems. Process. An operating system executes a variety of programs, batch systems or time shared system. It's a batch system. So it will be divided into process. Process is nothing but a program in execution. Process execution must progress in sequential fashion. The process includes a program counter, stack and data section. The process multiple parts. The program code, also called the text section, current activity including the program counter, processor register will be the part of the process. A stack containing the temporary data. It has the function parameters, return addresses, local variables. Next section is data section containing global variables. Heap is nothing but a memory dynamically allocated during runtime. Program is a passive entity, but process is an active entity. So execution of program started via GUI mouse clicks. Command line entry of its name. So one program can be several processes. Consider multiple users executing the same program. The process in memory, the stack will be having text section, data section, heap, so as the program counter, register, everything, and the stack. The process states. The process may be in various states. As a process executes, it changes states. New, the process is being created. Running, a process instructions are being executed. Waiting, the process is waiting for some events to occur. The process is ready, the process is waiting to be assigned to a processor. Terminated, the process has finished execution. So the diagram is given, the new to ready, ready to running to waiting. So it may be in any one of the state. So it's admitted, it's a new process, ready. Then it will be running with the scheduler dispatched means it will be running. After running, it will be get terminated. In abnormal condition, running process may be interrupted or be waiting for a IO event completion or IO event wait. Process control block. The information associated with each process will have process state, program counter, CPU registers, CPU scheduling information, memory management information, accounting information and IO status information. So the process state will be having a process number, program counter along with the registers, will be having a memory allocated for that, list of open files. So CPU switches from process to process. So process P0 is executing. Operating system will be having a status clock. A system call, the save status to the process control block. So read load the state from process control block. So till that process P1 will be idle. After that the interrupt will be called, say for example, then the save status in the process control block. Read load the state from PCB 0, then that time the process P1 will be idle. So process scheduling, maximize the CPU use, quickly switch processes onto CPU for time sharing. Process scheduler schedules, selects among available processes for next execution on CPU. It maintains scheduling queues of processes, job queue, set of all processes in the system, ready queue, set of all processes residing in the main memory, ready and waiting to execute. Device queues, the set of processes waiting for an IO device. Process migrate among the various queues. So process representation, so the stack it will be given in the form of structure. So ready queue and various IO devices. So each and every queue will be having a header. So the queue will be as per the data structure representation will be having a header and trailer. So various queues will be there for a disk, a magnetic tape and the terminal unit will be having so many number of queues. Representation of process scheduling, ready queue will be having an IO queue, then it will be a sliced one or a 4K child executes, so interrupt executes, so it goes on. The schedulers are long-term scheduler or job scheduler, selects which process should be brought into the ready queue. Short-term scheduler The CPU scheduler selects which process should be executed next and allocate the CPU. Schedulers will be fast, short-term scheduler. Long-term scheduler may be slow. This controls the degree of multi-programming. Processes can be IO bound process or CPU bound process. So more time doing IO means it's IO bound process. CPU means CPU bound process. Addition of medium term scheduling. Partially executed jobs, it will be swapped in and swapped out. So context switch, CPU switches to another process. The system must have the state of the old process and load the saved status to the new process via context switch. It is represented in the context switch block. Process creation. Parent creates process create child process, which in turn create other process. That will be a process tree. Resource sharing. Each and every process will have the process identifier. Resource sharing. Parents and child share all processes. Child share the parent status. Execution. Parent and child execute concurrently. Parent waits till it terminates. Address space. Child duplicate of parent. Child has a program loaded into it. Unix will be having fork to create new process. So fork to replace a process memory. Process creation will be having a fork. Parent, it will be waiting. Then the child will be executing. After that exit has to wait. So tree of process on Solaris. Process termination. So you have to give the statement exit. The parent terminate the execution of the child process. Have the concatenation also. Have the interprocess communication and the cooperating process. Independent process can be affected by execution of the process. So question is, how the links can be created? Can the link be associated with more than two processes? How many links can there be? Even pair of communicate process. What is the capacity of the link? Is the link of the message that it accommodate a fixed variable or variable? It's a unilink or bidirectional. Thank you. Thanks for your listening.